Okay, so we're going to start now. Welcome, everyone. This is our first webinar of Climate Change AI. This is our webinar series. My name is Felipe Oviedo. I'm part of the Climate Change AI team. In case this is the first webinar you're attending, we are like Climate Change AI is an organization composed of volunteers from academia and industry, and we believe that tackling climate change requires concerted societal effort. And within this context, we think that machine learning can play an impactful role. In this first webinar of the year, we'll discuss an important topic, equitable climate change mitigation. The questions that we want to address are first, how can we address climate change while addressing social inequity? And second, an open question is like, could AI or like data approaches help here? To answer this question today, we have three wonderful speakers with us. Sergio Castellanos from UT Austin, Donnell Baird and Doris Ham from Brock Power. During the webinar, each speaker will present their work for 20 minutes, so we'll have two blocks. And in the end of the webinar, we'll have an open dialogue and questions from the audience. We already got some questions from you in the Eventbrite, from all the attendees. So we'll have, we're expecting to have some like very interesting discussion. Yeah, without further ado, I would like to introduce our first speaker, which is Professor Sergio Castellanos. Professor Castellanos is an assistant professor of civil, architectural, and environmental engineering at the University of Texas at Austin. A pillar of Sergio's research is to evaluate the distributional justice aspects of clean technologies deployment, such as solar PV or electric vehicles, and elucidate areas for effective policy interventions. Professor Castellanos holds a PhD degree from MIT in solar photovoltaics and work as a postdoc and as a professional researcher at UC Berkeley. Without further ado, I will now give the floor to Professor Sergio Castellanos. Thank you.
Thank you, Felipe, and thank you to the Climate AI team for this kind invitation. I will go ahead and share my screen right now, and I'm guessing, can you see it? Thumbs up?
Yeah,
okay.
Well, we can see it.
Thank you so much. As Felipe was saying, I'm Sergio Castellanos. I'm an assistant professor at UT Austin, and it's quite a pleasure to be here today with many of you to talk about a topic that really drives us, and that is acting on climate with an equitable mindset. And to do that, I'm going to talk about the use of data in two specific examples, one in energy systems and one in transportation. But as I mentioned, it's mostly on the focus on data, not so much artificial intelligence. And the pillar and cross-cutting theme here is the aspect of inequities. And the thing is, we all have seen the historical evolution of persistent inequities, whether directly related to the hazardous waste disposal sites, to transportation access, to the siting of polluting power plants near communities, and also, the urban and housing planning discrepancy that we see reflected in many cities around the world. And the same goes for our climate crisis, that it's only exacerbated with the projected increase in temperatures for the future. So this projected increase in temperatures will only exacerbate the conditions, increase temperatures, also bring on natural disasters and amplify the humanitarian crisis that, as we have experienced in the past, tend to affect the most vulnerable. And I think this is the biggest piece that is often missed in our conversations. So therefore, we need to act swiftly, we need to act aggressively, and we need to use as many tools as we can. But we also need to ensure that this transition to a cleaner and habitable future is equitable, but it also includes benefit to everyone. So among the many tools in the toolkit that we can use, one that has gained clear attention lately is the use of data, and deservedly so. Data can allow us to describe a problem. We can diagnose it, understand the whys. With that, we can then predict when will that event or problem will happen again in the future, and ultimately propose a solution to counteract that issue. This community of climate change AI has done a great job of highlighting some potential ways in which different sectors are being disrupted and will continue to be disrupted. For example, in the electrical grid, we have seen evidence of material science evolving quite fastly to propose new materials, emissions modeling as well, forecasting supply and demand more precisely. The transportation sector, evaluating cleaner fuels, alternative modes for transportation, as well as evaluating the infrastructure quality in rapid ways. In terms of buildings, we have smart buildings, and we can analyze energy occupancy with IoT. In terms of industry, alternatives to chemicals and processes as well. That's one of the future paths to dig deeper. There's other component, which is the agricultural, in this case, for land use, remote sensing, and also evaluating how we can diminish the deforestation process. For weather, hyperlocal weathering forecasts are becoming more powerful lately, with different companies tackling this issue with the help of AI and machine learning. Financing, there's a lot to be done and great opportunities in terms of investments and analytics. And one piece, which is the social, which covers deployment, the adoption, but also what policies can be developed to enhance all of these other mechanisms that we need to move forward. And this one in particular, which is the social component, can be thought of as a cross-cutting theme, right? So we want to ensure that all these other pieces guarantee a just environment. And to put us all in the same definition of when we talk about environmental justice, the US EPA, Environmental Protection Agency, defines environmental justice as the fair treatment and meaningful involvement of all people, regardless of race, income, color, nationality. And when it comes to the development, implementation, and enforcement of laws, regulations, and policies related to the environment. So putting this into the context of where to focus the use of data and including EJ as a pillar, we see this graph. On the x-axis is time progression. On the y-axis, you see billions of people. So the UN estimates that by 2050, close to 70% of the world's population will inhabit in cities. This will only exacerbate their current role as the main locations for anthropogenic greenhouse gas emissions. So recognizing the role of cities in emitting greenhouse gases and bringing data into the equation, and bringing also the underlying goal of ensuring an equitable climate, this constitutes the pillar and driver for the underlying research theme that I'll be presenting today, which is how might we develop data-driven tools for an equitable climate change decision-making focus in cities. So let me start off with the transportation sector, namely in electromobility. This is electric vehicles, electric transportation. This has direct implications in greenhouse gas emissions, but also in climate change, both in the medium term and long term, as well as in air quality. And I present this case in an international context situated in Mexico City. This is one of the most polluted cities in the world, and there are more than 10,000 deaths attributed to poor air quality on a yearly basis. In terms of fuel consumption, there's more than 20 million liters consumed of fuel on a daily basis. So to address this issue, there was a collaborative effort between different parties, which is a recurring theme that you'll see on this discussion, the partnerships. And we partner international organizations, the United Nations, industry, government, and academia, got together with a goal of using data to evaluate different policies focused on electromobility to address both air pollution and climate change. And we did so by developing a framework that could leverage the large volumes of data. And this has the implications that could be used to refine the intended national determined contributions, could be scaled to other cities in the world, but it also merges this idea of how to bring data into climate change. What you see here is an image of the city of Mexico, Mexico City, depicted with colors for all the different congestion levels. So this is just massive data ingest over the course of several months. And we can start thinking about policies oriented in in terms of the geographical space. Depending on how traffic flows, we can restrict or allow traffic to be coming through different areas, specifically focused on vulnerable population, but also adding another component of time domain. And this goes in line with different policies that have been structured recently for pricing and location, or where to restrict, again, the traffic flow, but also at which times of the day. So one of the important things in here was that we tend to couple this with a vehicle emissions model to understand the potential reduction both in PM 2.5 and also CO2 emissions, right? So what would the policies be and how might they be saving lives at different levels? So the first policy that we try to think about and bring to shed some light on with all this data is what happens if we electrify the taxi transportation fleet. So with this, you see a color coding that goes from 0 to 60, and it goes from green to purple. Those are percent reduction of PM 2.5 from a baseline level. But you see, with this policy, if it's implemented, we would see like a 3% reduction in PM 2.5. If we increase the ambitions and we start thinking and investing in public transportation electrification, buses, we'd see about a 25% reduction in PM 2.5. More advanced and perhaps utopic at this point, scenario where we electrified all the light duty vehicles, we would see almost a 50% reduction in PM 2.5 and also in CO2 emissions. Now, this gives us a great understanding of the potential impact of policies if they're applied homogeneously. But as we have seen in the past, burdens are not homogeneously distributed. Right? So to resolve and quantify this environmental burden on a spatial resolved manner, we take inspiration from a tool developed by the California's Environmental Protection Agency and the Office of Environmental Health Hazard Assessment, which identifies the communities that are disproportionately burdened by and also vulnerable to multiple sources of pollution. So what you see in this image is the state of California on a census tract basis with color coding that goes from green, which is the lowest scores, in this case would be the best off, and red, which are the communities that are more vulnerable and burdened by the environmental exposure. So taking this and applying to the transportation sector, we start to resolve the different patterns for different pollutants, PM 2.5, PM 10, ozone, and also leveraging on this vast information about traffic that I just mentioned a few slides ago, we can start resolving how pollution affects different segments on the greater Mexico City region. Also, similar for vulnerable population, we map different indicators in the same region, and we weight them proportionally, all of these different ones that describe society, to reach a final indicator that allows us to visualize the areas where different infrastructure policies could be prioritized. And this will be mainly for improved infrastructure on transportation. So these analysis, combines different ways of and sources of data to capture the environment and social dimensions of the population affected by this sector. And our current work is expanding to build up on those indicators and take this to the next level. So one example in our quest to provide evidence-based information, we are evaluating each of these bus routes in the greater Mexico City region to understand how much they transit through different burden areas and gathering and processing data on their transformers capacity, for example, also on their terrain conditions, how steep is a given street, and also coupling this with financial aspects to understand the true viability of electrifying public transportation, in this case, bus routes, but starting again from a data-driven indicator that highlights both the population and the pollution variables coming into play in the city. And so we're trying to do this and bringing the equitable component that we're raising the voice of those who are marginalized and exposed to the full big picture of how do we best support decision makers in bringing technologies to them. Right. So furthermore, we're also expanding beyond Mexico City and other cities, as is the case for Mexicali in Baja California, but also for Oakland, California. So in this latter example, we are leveraging on data from the work of Professor Josh Apte from UC Berkeley and Aclima and Google, which provides hyperlocal air quality measurements. So perhaps many of you have worked with this data set, which is very rich. And from this, we're bringing this information to recreate this type of indicators at a city level. So we bring this source and other ones at high resolution to create tools that decision makers at a city level can bring. So in this case, what you see in this image is, again, an environmental justice indicator for the city of Oakland based on transportation solely, but then we can provide information on the different bus routes that tend to transit to the most burdened areas, kind of rank them, provide solutions and community engagement. So we provide also analysis on the rooftop potential on the blocks that are nearby those bus routes to create this participatory environment. How could they engage in the electrification of those transportation buses? But also on the private transportation aspect of it. So there's two components on this. And so we're trying to bring different data sets to highlight the component of, or the variables that would dictate where to intervene in a more prioritized way to provide incentives in this sustainable transition. So as important as is transportation, well, there's a quick error here, but the main source of greenhouse gas emissions is the electricity sector. And we have seen in the past that there's discussions about whether the incentives for solar are mainly attributed to the rich sectors. And so one of the questions that my colleagues and I had was basically these two questions. You know, when we look at the deployment of solar PV as we're transitioning to other sectors, how equitable has solar PV been in the past? And another question is, are there any signs of disparity in adoption among ethnic and racial groups and races? So to understand and analyze this question, again, using data, but looking at the communities that are more vulnerable, we use and leverage the vast amount of information provided by Google through their Google's project Sunroof. In this case, they take millions of oblique images and calibrate them against solar installation and electricity generation models. So they model basically the installation at a given point in time for every pixel, for multiple roofs. Then they apply their deep learning internal approach to calibrate and better determine what is a roof, what is not a roof, how much of that would be exposed to a given installation value, how much electricity would be generated, but also where is a given PV installation existing, right? So leveraging that vast amount of information, we then map this into the information from the census tract, the community service, the American Community Service, and we understand and try to shed light on how the adoption of PV has been. So what you see in this image, it's on the upper side, there's the census tracts that are being analyzed as a function of race and ethnicity. It's from no majority, which is a well-mixed census tract. There's no one race that is above 50% of the total of the census tract. And then there are different colors for the different racial and ethnic groups within those given census tracts. On the lower part of this image, we see on the y-axis the deployment of solar PV relative to this baseline of no majority for racial and ethnic group. And on the x-axis, you see income. So for multiple income buckets, we see how they're deploying PV. So when we start analyzing, we see that white communities, white census tract, majority white, tend to install above the baseline. It's like 20% or more across multiple household incomes. When we bring Hispanics into the discussions, we see that they install less, as seen in this negative value below the zero level. And that happens across all income levels. Same goes with Black majority census tract. As you can see, they start negative values, but they also continue. Then again, the important thing is that this is even controlling for the same income level. The Asian population has an interesting crossover point, but also, as you can see, the the bands in here are wider because of the lesser amount of data that is found. But the point is that white communities tend to install around, what we find is that white communities install around 20% more, Hispanic communities on average about 30%, and Black community, again, on average, almost 70% less than a no majority census tract. So this really brings more questions than answers. There are many hypotheses that we're trying to test and we're interested in. As you can see here on this image, these are credit scores per income. So you see that they're more spread on low income versus more biased and segmented to the right. So there's some hypotheses that maybe credit viability could be playing a role across different income buckets, but also across different racial and ethnic groups. My colleagues are also trying to understand the network diffusion mechanisms, but also some evidence of the diversity in companies that could be playing a role in the reaching of different customers and different populations. So, but answering, again, this type of questions really necessitates a multidisciplinary approach with different partnerships and also different perspectives on the table. So in conclusion, data can help us find inequities in our path to a sustainable energy transition. They can help us identify but more importantly, think collectively in how to solve these issues and create like an environmental, inclusive decision-making process. And the purpose of this, well, they're beginning on cities. In this case that I presented, the hope is that they could be scaled to many other locations to start acting in a more meaningful way. However, I would be remiss if I didn't mention that data by itself will not and cannot solve everything. This is, after all, an environmental, but also a people's problem. And this increases the complexity on accelerating, but also in coordinating activities. So we have indeed in our efforts found challenges. And the bottom line is that these data-driven efforts really need stronger engagements with society, with different organizations at different levels, but they have to be functional to ensure continuity as well. So with that, I'd like to thank and make an open invitation to chat about this topic more in depth, but also others that we're doing in my lab. So we're doing at this point the grid planning, adding equity metrics. As you can see in the upper image, we have different power plants, adding different indicators to bake this into the optimization process, but also using higher cutting edge tools to apply on buildings. In this case, GANs, to apply on buildings, to analyze and assess building integrated PV, but also energy efficiency measures. So with that, I will conclude, and I'll be happy to take any questions towards the end of this conversation. Thank you.
Thank you, Sergio. That was an amazing presentation. I invite people that have questions to hold them until the end of the second block, and we'll have a longer block for questions. I think Sergio introduced a lot of very important topics that we are going to keep discussing in the second block. And so I would like to start presenting our second block speakers, which is Donnell Baird and Doris Ham from Block Power. Donnell is the founder of Block Power, a clean tech startup based in New York City. Block Power develops portfolios of clean energy retrofit opportunities in underserved communities and connects those opportunities to investors seeking social, environmental, and financial returns. Block Power is backed by various reputable firms and institutions, including Capor Capital, Andreessen Horowitz, Erica and Wendy Schmidt, the American Family Institute for Social and Environmental Impact, and Salesforce. Doris Han, like our second speaker, I think she will join for the questions, is the lead engineer at Block Power. She focuses on developing smart energy solutions for buildings and leads the design and development of engineering software that serves the clean energy project at scale at Block Power. Doris Han holds a master's degree in mechanical engineering from Columbia University. Without further ado, I will now give the floor to Donnell and Doris.
Great to be here with all of you this morning. We are super excited about this conversation. It's our first engagement with this community. We followed you guys from afar and I'm just delighted to have the chance to share what we're working on. Really looking forward to feedback and your help and support and collaboration as we all try to figure out how to mitigate the impacts of massive imminent climate change. So I'm Danelle. I started Block Power 7-8 years ago. And we think there's a lot of use cases for machine learning and AI in what we do. Doris is much smarter on this stuff than I am, but I wanted to talk through some of the use cases and problems that we are solving for, that you guys could bring your expertise in support of what we're working on. So what do? We want to turn buildings into Teslas, right? We want to rip out the fossil fuel heating, cooling, hot water equipment. We want to rip that out of the building. We want to put in smart, all electric, Wi-Fi connected heating, cooling, and hot water equipment that's going to make that building have massive reductions in fossil fuel consumption. It's going to make that building healthier. It's going to save money on the building's energy costs. Just like Tesla is ripping the fossil fuel engine out of cars, we want to rip the fossil fuel engine and equipment out of buildings and heating and cooling systems in buildings. In particular, we focus on buildings in urban and financially underserved communities. So if it's a low income, suburban or rural community, we also focus there. And with that understanding of what we do, here's how we think about use cases for machine learning. We think there is a killer use case for the targeting of potential sustainability projects in buildings. There's 100 million buildings across the country. How do we sort and tier and organize and score the buildings that are most likely to benefit from a sustainability upgrade? How do we score the buildings that are most likely to complete a sustainability or green buildings upgrade, which is different from who benefits, who will complete it? And how do we create an environmental justice score for all 100 million buildings that includes data on the location of that building, the neighborhood that it's in, how close or how far that building is from dangerous fossil fuel emitting plants or factories? Like, there's low income communities in Los Angeles that are, literally down the block from giant oil derricks that are drilling for oil in LA city limits. There was an active, coal plant inside the city of Chicago. How close is that building to dangerous, harmful fossil fuel infrastructure? What is the history of redlining or limited access to capital in that building and in that neighborhood where that building resides? And so by creating these scores for likelihood of completing a retrofit, need to complete a sustainability retrofit, and a score that incorporates the environmental justice impact of greening that building, we can begin to sort and sift through the 100 million buildings in America and figure out where should we start as we work on the important mission of reducing greenhouse gas emissions from buildings, which constitute 30% of greenhouse gas emissions from our overall economy. And so machine learning is, critically can be used for targeting and sorting of these buildings. We believe in digital twinning of all of these buildings. And so we want to have digital twins of all 100 million buildings. We want to simulate sustainability upgrades, what mix and size and brand of equipment makes sense in each building. And then we want those digital twins and our recommendation engine to get smarter as we learn from real world projects being completed. We want our targeting and our recommendations to get smarter and smarter and more accurate. So we, and Doris, we built out that initial MVP product for machine learning and targeting and recommendation engines in 2017. And Been running it for a few years. Doris is in the process of like rebuilding it. And so that's really important. I think the last component of what I would say is incredibly important before I yield to Doris is middleware. I visited the Baltimore public school systems in Baltimore, Maryland, a year or two ago. All of the heating systems were 40, 50 years old, and there was a snowstorm, and the pipes froze in the buildings, but nobody knew. So there's about 50 buildings where the pipe froze overnight. That meant that the heating system could not function in the morning. So the kids got off the school bus, went into school, but there was no heat, and no one knew. And this is a totally ridiculous and solvable problem because we just need to use the Internet of Things to connect and communicate with all of the heating and cooling devices in the building. So a lot of startups have been talking about this. A lot of big companies have been talking about IoT. Few have actually pioneered how to do this. There are systems like Niagara, Google's building lots of people are building different systems to monetize middleware and energy consumption connectivity at the device level. But our view is from an environmental perspective and a greenhouse gas reduction perspective, middleware tools should be free. So what needs to be built is like the Mozilla Firefox version of an open source middleware platform that's going to connect with fossil fuel consuming devices in millions and millions of buildings for free, collect data, put those data into digital twins that run simulations, detect anomalies, send out automated alerts to people who manage and work and live in buildings, and basically kind of create like a free Nest thermostat in the cloud for all of the devices that heat and cool our buildings and hot water, and that are wasting hundreds of billions of dollars per year paying for fossil fuels that we just waste, and of course are using to bake the planet. And so we really believe that an open source middleware platform that's free, that can collect data, detect anomalies, connect to different devices and have interoperability is critical. And there needs to be a community of folks like you who work on this. That middleware platform needs to provide two-way communication so that not only can we collect data from the devices and equipment in buildings, but that we can also push commands back to the equipment and devices so that if a building is wasting fossil fuels, we can remotely turn it off. And of course, build a machine learning model that learns, that's self-learning, and can start to optimize the ongoing operation of fossil fuel systems so that we can reduce waste. And so I will stop there. I think if we can build these tools, it will have a dramatic impact on the millions and millions of American buildings that are located in zip codes that are financially underserved. These buildings are old, their equipment is old, the buildings are unhealthy, they haven't had access to capital, they don't have professional maintenance staff who can take care of the building and help maintain it. So these buildings are neglected, they're health hazards, they trap indoor air pollution and recirculate it. They recirculate COVID-19 from apartment to apartment or classroom to classroom. These buildings are dangerous. They have lead, they have asbestos. So as we green these buildings, there's a public health impact, there's a financial savings impact, right? There's the greenhouse gas reduction impact, and we're able to create jobs in low-income communities, and of course, improve the comfort and quality of life in all of these buildings. And so machine learning is critical, again, to target these buildings, to build digital twins so that we can make recommendations for sustainability upgrades, again, for free, and to build a middleware platform that can collect data and push commands back to buildings so we can optimize their performance in the same way that Nest thermostats try to optimize, heating and cooling performance in certain kinds of single family homes. We need that for all energy devices. I'll yield to Doris. Do you have comments that you'd like to add?
Hey everyone, thank you Danelle for the overview. And Danelle have gave us a very high level overview of what we are trying to solve. And also I want to add more from my perspective from a building science engineer before and transit to a more data-driven approach to solve clean energy projects. For several products we have been built like for the past several years, what we're trying to do is to collect data that used to be collected by energy engineer like me. And an energy engineer used to spend like couple dozens of hours like trying to understand the building, trying to put the data together and trying to give a recommendation of energy efficiency upgrade. It is a very time consuming like process and it is very labor intense process. That's also the reason why a lot of small to medium sized buildings that may not have the chance to get being serviced by the energy efficiency industry. So what we're trying to do is to look at all the project we have worked on before and try to build machine learning model to have a smart recommendation engine that can just use several data points to understand what's the best energy efficiency upgrades that can be. It helps us a lot, not only because it's lowering the engineering cost, but also it enables us to serve more community that, especially in the underserved community that they never get a chance to like be served before because the high engineering cost. So that's how data-driven data science and machine learning that help us to serve more clients that is in need. That's just one point I want to add. Thank you.
Thank you, Doris. Yeah, I think that was a very interesting, you made very interesting points. And it's super interesting to learn about like what kind of products are you guys building and how you're thinking about this in like such a holistic perspective. So now we would like to move to questions. We have a first question that we have put together and we are compiling questions from the audience. So I invite people that have questions to include them in the chat as well. So our first question is, we saw a commonality between both of your set of works, in the sense that like both Sergio and Block Power, you are like, of course, one is industrial, the other is academic, but like you are deploying AI solutions and like data solutions to help traditionally marginalized stakeholders. This is like different that, for example, what large tech companies do, where they deploy like AI solutions or like data solutions. They have a different like mindset. Maybe you could like talk a little more about how you think about this process of deploying for social justice and like developing products and AI for social justice. And if you have some advice for people that would like to follow this model. So maybe I will start with like asking this question in specific to the Block Power folks.
I'm sorry, I didn't follow the question.
Oh, of course. The question is, you are deploying AI solutions or planning to deploy AI solutions for like marginalized stakeholders, no? And for like social justice. So how is that different from deploying solutions for like we see most of the time, like big tech companies, right? Or like with a more like purely commercial mindset in consideration?
Okay, yeah, I mean, I think in some ways, if you look at like, to me, Firefox versus like, I don't know, Chrome, right? If Google Chrome, they're both browsers, but Google Chrome is, monetizing all of your data. can we come up with a business model that isn't dependent on overcharging buildings for middleware software and for IoT software? Like, can IoT software become a commodity or a free commodity that enables other kinds of transactions? So you can create like an IoT enabled marketplace where you have your free middleware platform that's helping a school system, operate its equipment in a sustainable way. And then when that equipment is reaching its end of life, the equipment sends out an alert to all stakeholders, hey, I'm 12 months away from failing. And therefore, the machine learning has done the anomaly detection. I'm underperforming. I need to be replaced within the next 12 months. And so please order a replacement to be installed, right? And at the point of that order and that transaction, let's say you become the Amazon.com of green equipment, once that order for a new replacement heating system is made, you can charge a transactional fee on that order and thereby use that revenue from the transaction at replacement for funding the ongoing maintenance of the free open source platform. So that's one thing I would say. The other way of thinking about your question is like, are the buildings that like a Google or an Apple or Facebook, the buildings that they use themselves, their headquarters or where they locate their data centers, those buildings are at the very top of the market. Microsoft has an internal IoT platform that they're very proud of at their headquarters. That's top of the line. How do you extend that kind of IoT platform to everyone in a way that's affordable? And so you could do like a freemium model, right? Where if you're like a low income building, you get X amount of services and connectivity for free. But then if you want, more higher end services, then you pay a monthly software as a service fee or something like that. So there's different ways to monetize it. But in my view, from a climate change perspective, the fundamental premise needs to be, there needs to be an easy to use browser-like open source platform that provides free connectivity and interoperability of devices that waste and consume fossil fuels. That is the premise, and how you monetize and fund that ongoing business model. I think there's a range of ways that you can do it. So Juan, I don't know if that helps.
Yeah, no, that's very helpful. I think, I think that was a great answer. Sergio, do you have any views from your side? Let's say more from an academic policy perspective, or what do you think about that?
Yeah, absolutely. Well, when it comes to using a given tool, the process for us has been, we start with an idea, we think we know how to get there, but the interesting thing is that pretty soon after engaging with different folks, stakeholders, our goal changes. And so I've been appreciative of that process because, it really brings the reality check for the academic environment and try to connect in a better way to making an impact. And so that was reflected in actually the articles that I show, the works that have been done, and that iterative process also changes the type of tool that we decide to use. So we don't, at least what we've done in the past, we don't start with the tool like I want to apply this new method and then look for the question, but rather, okay, what are the pain points? We think we can address them in that way. We get some feedback, we reorient the question and the method, and so on and so forth. So it's been a process that all along it's backed by data because we want to provide evidence-based solutions to pressing issues. But again, as I said, it's an ever-evolving situation from our end.
Thank you, Sergio. That's also very helpful, I think. So I'm checking questions from the audience. So one question is, given the COVID-19 pandemic, we have seen like certain social inequalities have been exacerbated, and many are related to climate change in a way. In the aftermath of this pandemic, considering, for example, the recovery packages and like new policies in place, what do you think are opportunities or challenges in terms of equitable climate change mitigation. Maybe Sergio would like to answer that first.
Yeah, I think, in a way, it's it is bringing to the forefront these inequalities, and we see them they have been presented more clearly, right? And so a lot of the conversations that I've come across now are really thinking into this equitable action to address the pandemic. So I do hope that mindset persists also, when it comes back to tackling climate change issues. And so that's the hope, but it's also the challenge. Will that be the case as we move also to investing and deploying different tools and efforts to address our climate crisis? Will it be in the same manner? Are we going to be as fast as we're trying to be right with COVID? I think in the past the answer has been not so fast, not as fast as we need to be, right? But perhaps this mindset of being in a very dire situation could help in that process as well. So that's a little bit where I stand.
Donald, any views from your side? Maybe like the Biden plan, economic recovery of like retrofitting buildings, etc. Do you have any points on that?
Yeah, I mean, me and Doris fundamentally believe that retrofitting buildings solves like 4 overlapping crises, right? We have an ongoing climate crisis, we have a public health pandemic, we have an economic crisis, we have a racial justice and wealth inequality crises, right? If you focus on greening buildings and reducing fossil fuel waste in buildings in financially underserved communities, in communities of color, the city of Detroit, the west and east side of Philadelphia, Flint, Michigan, Oakland, California. If you go into these communities and you say, we're going to do smart, green, distributed infrastructure connected to a middleware platform, and that infrastructure, this new smart equipment that we're installing in buildings, it's going to reduce fossil fuels, it's going to improve air quality and health, it's going to remove COVID-19 from circulating inside a dense, apartment building in the Bronx or in LA or Oakland, right? Mm-hmm. Now you're addressing all 4 of these crises simultaneously. If you're training and hiring local workers, you're getting them training on how to operate and do construction in a public health crisis, but you're certifying them to install high-end, top-of-the-line equipment from Mitsubishi that's going to reduce fossil fuel consumption by 75%. If you have a plan and a program to green buildings in this fashion and move them from fossil fuels and create a diverse workforce with people of color from low-income communities, you're not only addressing an environmental justice challenge, you're addressing all of the challenges that are facing our society. You're helping us deal with the public health crisis. You're reducing asthma and other comorbidities of COVID-19. You're creating jobs and you're building long-term wealth, particularly if in low-income communities, when you install this equipment, there's an ownership share of the distributed green infrastructure or the middleware platform. I saw in the chat that someone asked a question, well, what's the business model? Why not have a co-op, right? And or why not have it be crypto, right? Hey, if you work on this middleware platform and you put it in your building, you're entitled to XYZ amount of tokens. And as more people work on this middleware platform together, we're productively crowdsourcing and increasing the value of the middleware platform. So at some time when the Biden-Harris administration invests money to expand it, or people start, or Amazon wants to buy it, or whatever we decide to do, these tokens become more and more valuable. The project that Doris and I are working on is how do you tokenize carbon offsets? And so you could say, all right, we're going to build a free middleware platform for everybody. Anyone who works on it is entitled to the carbon offsets that are produced by the work that they help to do, by the input and the contribution of code that they made to the middleware platform. You are now entitled to XYZ amount of carbon offsets. So when we go back into Baltimore and reduce fossil fuel waste using the middleware platform, that's going to produce X amount of carbon offsets, and you're entitled to a percentage of that, which you can sell to whoever. You can use it, the next time you travel, and offset your own footprint. I think there's multiple ways to kind of monetize these kinds of things. And I forgot to mention, the Obama administration had actually invested in an MVP open source software platform like this. And so they worked with Virginia Tech and some universities, I think the National Renewable Energy Lab in Seattle and the one in Berkeley. And they built out an MVP version of an open source middleware platform. There is just no community of developers who are working on it to move it forward and remove the bugs and figure out how to monetize it and drive it. Of course, if Hillary Clinton had won the presidency, then maybe her administration would have continued to invest in it. So it's just been laying dormant for 4 years with no attention, and it needs a community of people to kind of adopt it and figure out what to do with it. So that's one of the things I wanted to talk with you all about.
Great. I think that's a very interesting point. Like, I think there's a lot of questions in the chat. So what we're gonna do later is have a forum, like in our CCI forum, we'll have a thread, and like I will invite the speakers to comment more on that, like async. I will ask one more question, and then we'll close our webinar. The question is about data. So what do you think is the role, or how important is the role of open data in the kind of like projects and models you're working with? I will start with Sergio, maybe from the perspective of research and policy, policy informing, etc. So Sergio?
Well, quite critical, right? I don't think any of the projects that we've worked with would have been possible without any sharing of data. And so I think that the community has been changing towards that. Now, when you publish something, you are required to share the data or just be more open about it. So I think there's some positive trends overall, but there's also companies are more venturous in trying to be open about it. They make you sign NDA. So I in the past I have done that, but once that best practices are starting to evolve, I think that really triggers a cascade of positive benefits. So at the end of the day, the more data, the better for many ways and many reasons. So it's crucial.
Then like the same question for Donald is, in your case, I think you're depending a lot in like IoT and like sensing for like getting some of this data and having like some sort of data pipeline in this scenario. Do you think having some sort of open data or like more access to like this kind of data is important, and like what kind of data will be useful for you guys?
Doris, do you want to answer? Because Doris is in the middle of compiling a bunch of data sets across the state of New York and across the country. So Doris, do you want to talk everybody through that?
Sure. That is like definitely very critical for us as well. We have built our several data product that is based on both public available data as well as proprietary data we have in-house. And the data such as like the building, because we work a lot with different buildings, the building, like data, open data around buildings such as geometry and the history, like year built. Such parameter is very crucial for our model to operate. I would say, like I see the trend, like data complete, like it is becoming more and more complete and easy to get from the previous CSV file on all the website now to most of like the open source has the API that is very easy to use. Yeah.
Wonderful. Thank you, Doris. I guess like a follow-up question for that would be, let me just check we still have time for one more question, so I will check that. I'll check the questions from the audience. Yeah, I think this is a good point. Is like, I think like one part of like public opinion or like even like policy making says that like if you address this issue in marginalized communities or like with like leading to like more equality, etc., usually it's not seen as a good investment. or we see that like pretty often. So the question is like, how do you influence the general public and policymakers to consider this as an important topic and like these kind of approaches as useful tools?
Yeah, I'll start, and then if Sergio wants to add, I mean, look, I started out as a community organizer. Like I didn't know anything about business, capitalism. I was a community organizer that was just trying to figure out ways to help people, and ended up working for the first Obama campaign because he was trained by the same community organizing supervisors that I was, and I liked him and thought he would be a good vice president to Hillary. And anyway, the long and the short of it is, as I learned about the green buildings industry and what was possible in terms of job creation, wealth creation, and also, you know, averting climate change, I just became laser focused on this industry. And but I still wanted to help people, and I still wanted to reduce climate change. It just turns out that if you look at 5 million medium-sized buildings, so not the skyscrapers and not single-family homes where there's 100 million, but 5 million schools, churches, synagogues, mosques, small businesses, those 5 million buildings waste $100 billion per year on fossil fuels. That's not what they pay. They pay 300 billion. They waste 100 billion. So if you can reduce that waste in these buildings, there's more than enough money to subsidize or provide revenue to a middleware platform or anything else, right? So I do think that we at Block Power, our priority is helping people, second only to dealing with the massive disaster of climate change. But there are billions of dollars to be made here. There's a question of who will make that money. Is it going to be some massive corporation, Google, or is it going to be a software platform that's owned, controlled, developed by and for communities like this one so that it's optimized for the correct outcomes? Or is it going to be like another Facebook where, you know, they do crazy shit and ruin the whole society? So those are the questions, but there's significant capital that's available in this market. It's not just because the people are poor doesn't mean there aren't hundreds of billions of dollars being spent on fossil fuel energy.
Yeah, I agree. That's a very interesting point. Like like this opportunity cost in a way, right? Sergio, do you have any comments on that or any?
Yeah, very briefly, just to say that, you know, we have found policymakers across the entire spectrum. Some of them really don't care at all. You know, they just want to see like the big impact on something flashy, but some other have actually approached us, you know, with questions and concerns and trying to dig deeper. So I think, you know, it's hard to generalize, but one of the recurrent things that has been helpful all in all is to really craft the message in something they can quickly capture. So whether that being, you know, as it was just being said by Donald on, you know, the millions of dollars or emissions. So trying to quantify that in some way that really captures their motivations. Lives saved, for example. I think that's one big thing that has or needs to be continue to be done to really bring this message home. Hopefully, you know, the mindset will continue to evolve and have this in the top of their agendas.
Great, thank you, Sergio. So yeah, I think like we are on time. I will let the speakers, if they have any final message, just feel free to chime in. And if not, we'll close this webinar. And thank you everyone for attending. Thank you, Doris, Donald, and Sergio for your great presentations. And we hope we can continue this conversation in the forum or like Twitter.
Yeah,
mail.
we've been delighted. This is awesome. You guys got an amazing community, so we're happy to participate. Sergio, nice to meet. Take care.
Likewise. Thank you so much.
Bye-bye.
Thank you.
Thank you.
Okay.